Download the app now.
Hi, welcome back. In this session, we'll see some questions. We'll learn some concepts of network analysis with the help of some basic questions on AC circuits. This AC circuits is pretty much confusing to a lot of students, but it is easy at the same time. You will feel difficulty because you're not aware of the topics. Okay, so I'll roll some questions over here. I recommend you to solve the questions, if possible, without your notebook. If that is not possible, you're even allowed to bring your copy. You can keep your copy alongside and you can try to solve it. But with book or without book support, whatever the way, the objective is to solve the questions. Okay, so they are easy to solve if you pay attention. Okay, but the concepts behind those will be very interesting. Okay, simple concepts. And these are some of the questions which are given in the previous exams. You call it state electricity boards, different states electricity boards. You call it ISRO, different state exams or central exams. So based on those, I just change the order in a proper way. Then I come up with the questions. Okay, so let's start with the first question. So what you have to do is, when you have a question, you take a minute time and try to solve that question within that 1 minute time. Okay, yes, question is on the screen, timer is running. Yep, go. Simple one. If possible, you can take a copy or without copy, whatever, but you have to answer. Yeah, that's good. Some questions you should be able to answer just by looking at it. Okay, but next questions may not be that easier. Okay, so almost everyone answered correctly. I'm still looking for some of the answers. Satish, you just mark your option as D, okay, so that it will record the system. What we have will record it. Okay. Yeah. Time's up. Time's up. Let's now see the solution. Okay. Let me explain in a brief way. So everyone answered actually D. Okay. So yeah, that's a good thing. Very good thing. Impedance Z1 is given, Z2 is given. Yeah, this is one of the previous questions. Okay, previous state electricity board questions. Z1 is given, Z2 is given. See, here objective is to learn as well. Okay, learn as well, not to answer the questions. So Z1 by Z2, Z1 by Z2 is equal to 20 at an angle 50 by 10 at an angle 30 degrees. So numbers, you will divide magnitudes. The magnitudes, you will go for normal arithmetic division. So 20 by 10, which is 2 at an angle. So all are having 2 at an angle. So the only key thing is, you don't have to even find this magnitude, you only have to figure out the angle. 50 by 30 degrees means 0, 0 cancelled, 5 by 3 angle. No such angle. You should not do that. When you have angles at division, you have to subtract them. Means 50, this angle goes to the numerator, minus 30 degrees. So 2 at an angle 20 degrees is answer. Because whenever you have something like x at an angle theta by y at an angle maybe alpha, so this answer will be simply x by y at an angle theta minus alpha, because it's a division. If it is in multiplication, if this and this are in multiplication, this will be multiplied and the angle will be additive. That's a known thing. Okay, so based on this, next questions are interesting. Okay, you should answer that as well. So for now, 2 at an angle 20, these answer. So first question, it becomes too easy for you. Yeah, I know that. So let's see what we'll do for the next question. Okay, yeah, on the screen now. Really good questions are there. Okay, simply Satish, I want you to register your option as simply B. Don't describe anything. Okay, it's good. Just by looking at you're able to answer, that's good. But you have to just give option B. So simple questions. I expect everybody to respond for this. You should try. Don't just look at it. Very good. So we got beautiful explanations as well. Okay. Sai Ganesh has explained nicely. Yeah, time's up. So good, Sai Ganesh, keep it up. Let's now see the solution. Okay, mostly people have opted for option B. Okay, let's see whether it is right or wrong. Square root of 64 at an angle 36. Again, this is also previous questions, one of the previous questions. Means square root of 64 at an angle 36 degrees. So square root of 64, which is 8, already all options are having 8. And this is 36 square root means 36 to the power 1 by 2. Means you have to make this angle half. 36 by 2. 36 by 2. So the answer is 36 divided by 2. Answer is 18. 18 degrees, 8 at an angle 18 degrees. So mostly people have marked correctly, but some people still they got some confusion with option A. Means they took a root for this 36 also. 36 under root is 6. So they opted for A. That's not correct. Okay. Anyways, that's a good try. Good try. Next one. Go for it. Good. These are simple observation questions. I don't think you should take a minute time also for this. Maybe less than that, you should be able to answer these questions. But the next concepts are based on this. Okay. So I just ordered them, in a sequence so that you will feel easier. Slowly we'll build to a tough level questions. 10 seconds more. But yet, I know people are not responding. What happened? Huh? What happened to you all? So simple questions also, if you're not responding, that's too crazy. Anyways, time's up. Your time's up. Less responses, but everybody marked for option B. Okay. So when the phase difference between two sinusoid quantities is 90 degrees, I think by now you're already aware of few facts like what's the need of Phasor diagram? Why you should go for Phasor diagram? And why sinusoid? Why 50 hertz? Why 11 kV? All these basic points, I think you must have got a clarity on that. Okay. If not, check the videos. Check the videos. You will get a much clarity on that. On YouTube also it's available from our channel. Okay. So when you have two phasors which are of 90 degrees, you will not say phase right angle, they're right angle to each other. We'll not say that. We'll say they're in phase quadrature. If the angle difference is 0 degrees, then we would call it as they're in phase. If the angle difference is 180 degrees, then we'd call it as out of phase. Okay. So there are basically three terms: quadrature, in phase, out of phase, and then leading, lagging. Okay, so these terms we clearly explained with the help of beautiful animations. I think you must have got that idea as well. Okay, it's good. It's good. So Upendra also has shared something. Electrical quadrature and the coordinate system, it's right angle. Absolutely right. It's a good one. Anyways, moving on to the next question. Okay. So, but the responses are pretty less. Okay. Yeah. Go for the next. This is also easy, right? So with this momentum, you should keep this positive motivation to answer next questions. Okay. Just starting off the session. Try to answer it. Cool. This J term is very key thing. That's one of the key things, to understand this phasor system. Okay. 10 more seconds. I think people have marked it so far. The response have been impressive. Really impressive. J means angle 90 degrees. That's not enough. Angle 90 degrees in which direction? That also you should say. To be more precise, angle 90 degrees in which direction? Clockwise or counterclockwise? You have to say that, Sai Ganesh. That's also key thing, right? Anyways, your time's up. So everybody marked for option B. That's good. Let's see what's the right answer. If a phasor is multiplied by J, where J is an operator, what's the J operator? Tell me. Write somewhere. What's the J operator? I'm listening. I'm listening. Tell me. Speak out. I'm listening. Yes. J is 90 degrees counterclockwise operator. You have to say this. J means plus J is 90 degrees counterclockwise operator. It only changes the direction. Okay. Then only its direction changes. Magnitude doesn't change. Only the direction changes by how many degrees? 90 degrees counterclockwise direction, to be more precise. Okay. That's cool. Very good. So next one. Try this out. Try this out. What happened? So far you've been so quick. Now you lost the momentum, huh? How come? Everybody's quiet, it seems. We got an answer from Sai Ganesh. Just 3 more seconds. I'll wait for some more time because people, I think they are doing. What's a big thing to do here? Is there something missing here? What's up, guys? You're gone. You're dead. Okay, let's see this. It is said polar form of 1 minus alpha square plus alpha, where alpha is given as, we normally take it as Z, okay, plus 90 degrees is Z. According to our terminal, just now we have seen that. But now he tweaked a bit. He started saying it's alpha, it's his wish, right? Some people call it as a sigma, some people call it as a K. It's up to them, okay? So in mathematics, they would call it as I, okay? But in electrical, we don't want to bring extra confusion because I already we assigned that I to the powerful current, okay? So we don't want to bring extra confusion. That's why we converted that I into J. But according to mathematics, it should be represented as iota I, okay, in complex numbers. Anyways, now it is said Alpha square, just focus on alpha square. What is alpha square? We have a vector 90 degrees means 90 degrees counterclockwise once. Alpha square means one more time 90 degrees. So alpha square is, if 1 is here, 1 into alpha square is completely 180 degrees opposite. Now minus alpha square is, what about minus alpha square? Minus alpha square is again 180 degrees more. So this is nothing but plus 1. I hope you got the point. Let me just explain it again. This minus alpha square results to plus 1. Not minus 1, plus 1. Alpha square is minus 1. Alpha square is minus 1. Minus alpha square is minus of minus 1, which is plus 1. So 1 plus 1 is 2. Now he's all asking about 1 plus j simply. 1 plus j. See, this is I according to us. Whatever he gives, we know it is j. 2 plus j, he's asking in a polar form. And you all got trapped just for this. 2 plus j is in polar form. At least try now. 2 plus j in polar form. Do it. You don't have to, that's what, you don't need a calculator. Why do you need a calculator? For finding out angles and all, you don't need a calculator. But just by looking at this, 2 plus j comes in first quadrant. It comes in first quadrant. So this is wrong answer. This is wrong answer. This is wrong answer. The only right answer is this, because without even I'm doing any math, without touching a calculator, you could do that. Because it is in the first quadrant. And out of all these phasors, these are only phasors which can be located in first quadrant. So this is the only answer. Or else if you want to solve it, root 5 is 2.23 something. An angle, yes, first quadrant angle, 63.48. Tan inverse of 1 by 2, you just do that, you will get that. Okay. So, yeah, answer is D. Some Sai Ganesh have marked it. Okay, that's good. Keep it up. I'll move to the next question. But I could see only few responses only for Sai Ganesh. We can have a blast. Okay. Moving on to next. Bang. Here you go. Solve. A simple one, right? So when you say simple one, there is a tough one ahead. Okay. Yeah. Nine more sec. Time's up. This is a simple one. Again a simple one. The period of a signal, time period is asking about time period. How many seconds? These are all in seconds, time period. Okay. So the question is about the time period. So you got a signal. There is a signal. It's also for time period. Come on. This is omega t. Omega t is equal to 0.8 pi. Means 2 pi f is equal to 0.8 pi. Omega t is this much. Okay, so pi gone this way. So f is equal to 0.4. So 1 by 0.4. Time period is 1 by frequency 1 by 0.4. That's answer. Okay, so it's 2.5 because you multiply both sides with 10. I mean, up and down 10. 10 by 4. 10 by 4 is 2.4 seconds. 2.5 seconds. That's the answer. Simple. Okay. So people are marked for wrong answer. I don't know why. What happened to this? 1.25. On what basis you've done that? Did you do something wrong or something like that? Omega 2 pi, yes, absolutely right, because everybody marked wrong. I don't know why. What happened? Oh, some people are marked wrong, not everyone. Okay, next one. Here you go. Try solving this. Easy one once again. Sampath is back. Raju is always on time. Tirtish. Good. That sounds good. Impressive. Everybody's marking for C. Let's see whether it is right or wrong. Just 5 more seconds to go. So everyone opted for C. That's a good sign, but we have to check whether it is right or wrong. Okay. Let's see. Generating stations, we will do that. The time period of third harmonic of power supply. Third harmonic means whenever you hear a term, Phasor diagram, whenever you hear a term harmonic, normally students do get frightened. I don't know why. But I think after watching these animations, PiSquare animations, I don't think you should face any problems with the Phasor diagram. And harmonics also, it's pretty easy. It is said third harmonic. So the fundamental is 50 hertz. So the third harmonic is F1 is equal to 50 hertz. 1 stands for fundamental. So F3 is equal to simply third harmonic F3 for. So 3 times of F1, which is 150 hertz. So he meant to say, what is the time period for 150 hertz? That's the question. What is the time period for 150 hertz? So just go for 1 by F3. There you're going to get T3, third harmonic time period. So 1 by 150. Or else, you know already for this time period is 20 milliseconds. 20 milliseconds is for 50 hertz. That's pretty much known to us because 50 hertz is quite common in India. Okay, and why 50 hertz is used, all content is there on YouTube also. I think you're already aware of it. Okay, so now third harmonic means if it is a frequency 3 times higher, but if it is a time period, reciprocal, right? 3 times lower. Okay, so 20 milli by 3. Okay, so it is asked for milliseconds. So simply 6.66 milliseconds. So 1 by T3, this is going to be 6.66 milliseconds. Units, it is asked for milliseconds. So that's why I'm directly marking 6.66. So that's a good job. Okay. Next one. Everyone made it right. Okay. Next. See, though they are numerical type, but we didn't use the calculator. The practice, when you're practicing it, these things can be done very easily. Okay. Okay. So time's up. Again, everyone opted for option C. It's about the peak factor. Okay, so what's the crust factor or peak factor? Peak factor is equal to peak value by RMS value, whereas the form factor is equal to, try to recall other factors also, RMS value by average value. Okay, and for a sinusoid, what is RMS value maximum value relation? You have to write all those relations. Anyways, in the next question you're going to see that it's the ratio of average value, no it's wrong, maximum value average value, no it's wrong, ratio of maximum to the RMS, yes, as per the definition, that's right. Okay, so next one. Good, keep it up, keep doing that way. Don't just try to put a random answers. It's okay if it is wrong, but it cannot be so random. Okay, it should not be random, rather. I don't know how come you missed this question. Some of you are opting for option A. That's not quite acceptable, but okay, mostly people opted for correct answer. Okay, so let's see how to handle this. A sine wave has I think sine wave has a peak value of 12 volts simply. It doesn't matter what's the peak value. It doesn't really matter what's the peak value. For this, maybe a crust factor you call, or peak factor you call, or a form factor you call, the wave shape only matters. What all matters is the wave shape. Okay, let's take for a sine wave, the maximum value, let's take it as Vmax, some maximum value, and the RMS value is Vmax by root 2. That's what the relation between maximum to RMS if it is a sine wave. If it is a sine wave, if it is a different wave, answer will be different. So this is what the crust factor or peak factor, so the value will be root 2. Okay, so here what's the value of Vmax, it doesn't really matter. Okay, because anyways it get cancelled out. So answer is C, root 2 is 1.414. So option C is the right answer. Okay, that's a good one. Next question. Yep, I think देख के हो जाएगा इसका. You can just have a look at it and answer it. Because it's also a formula, right? If you really know the formula, you can mark it. If you really don't know, then you will end up in marking wrong. You'll end up in killing your time as well. Okay, that's when the class I give a table for different wave shapes. What is its average value? I recommend you to bring the table. Keep the copy in front of you. Try to mark those for a sinusoid, for a triangle, for a sawtooth, for a square wave. What's the average value? What's the RMS value? Then what are these factors? Once you have these figures, average value, RMS value, with respect to maximum value, the factors can be easily can be done. And for electrical people, these formulas should be related backhand because they will be used rigorously in different subjects as well, including power electronics. Okay, so if you have these things in a hand, things will be a lot more easier. And surprisingly, everyone marked correct. That sounds really good. Okay, anyways, let's see. For a sawtooth waveform, or maybe if it is a triangle also same, for a sawtooth also it's same. The relation between maximum value and RMS value is, if it is a sine wave, the relation is maximum by root 2. If it is a sawtooth wave, it is maximum by root 3. Okay, for different wave shapes also you try to make those things. Okay, now As you have done this nicely, next question also I think you'll be pretty much able to do it. Okay. That sounds good. I think we got some nice people joined in the session. Tesla also joined. Sanjeev has joined. Prem has joined. That's gonna be something interesting now. The real competition is in. See, being quick is not enough. Being correct is also important. That's a blast. Very good. Blastful performance. That's good. Let's see. In which of the following waveforms RMS value is equal to average value? Average value, RMS value equals, here this is ambiguous question to be more precise. Okay. So for a triangle, definitely that's not the case. Average value, RMS value is not same, because for average, what's the average value of a triangle? It is average value of a triangle. Yeah, half. RMS value is by root 3. Okay. For a sine wave, for a square wave, actually average value is 0, right? Even if you say a triangle, if it is bidirectional triangle, the average value is again 0. Okay. So, but when you look at a question, you should not go for none of the above. Okay. Because this is PYQ, previous year question, it is asked for. So, you should be thoughtful in putting your answer as well. When they said average value, you should not strictly take average value, you should take full wave rectified value. Means a negative value, if it is there, you should understand the sense of the question. Okay. So when you have a sine wave, you should take magnitude only. You should take this on the positive side. Okay. Triangle also you should take in the positive side. If it is a negative side, only positive side to take. Means full wave rectified sine wave, full wave rectified square wave. That you should take. Okay. So when you're taking that, this square wave is no more is going to be the square wave. It is going to be constant, simply constant after rectification, full wave rectification. So it's simply a DC. It's simply a DC. So when it is a DC, for a DC, maximum value, average value, RMS value, it all the same. Okay. So this would be the, I would prefer this. I would prefer to mark this, but if you just take the question only, not the sense, then you have to go for none of these. Okay. But here, don't take literally the words. You have to understand the sense of a question. Okay. I hope you got the logic behind marking option B. Okay. Anyways, moving on. Try this out. Easy one because we had done the previous one, so it should not be tough. That's it. There you go. Blast. Quick answers. Very quick answers back to back from different people. Okay, I think everyone marked. Those who normally mark, other people are just waiting, I think. Good. Sai Ganesh. So simply we have seen in the previous formula, I think we should not waste much of time on this. Okay. Why? Because we have already seen this. For a triangle wave, the relation between maximum and RMS is by root 3. So 3 by root 3, maximum is 3, for RMS value maximum by root 3, which is 3 root 3. No, just root 3. Okay. Answer is A. Next one. This is also easy one. I think we already solved this in the previous case. See, for such easy questions also, if you're not responding means what to say. Huh? You're not thinking, you don't want to think, or you don't want to respond. Good. Wow. That's really good. Everybody mark for option C. Okay. So let's see whether the C is right or wrong. I think it must be right because we already seen for a square wave videos also we have seen that already. It's a relation between RMS value and average value. We have even seen that. We've seen that RMS value of the current is less than average. No, RMS value of the current is equal to the average. Okay, so basically form factor is 1. The ratio is form factor is 1. That's equal to be more precise, the maximum value. Okay. Okay. Yeah, basically same question in a different way. Way has changed, but same question. Maybe a different exam, I think. Different exam, they tweaked a bit. And yeah, they gave it. Next. Time's up. We got a mixed answer sadly for this. Low response, at the same time mixed answers. What happened, huh? B, C and all. Okay, let's see what is right, what is wrong. Which of the following waveforms has lowest form factor? Form factor is ratio of RMS to the average value. Am I right? So ratio of RMS to the average value is a form factor. What's the form factor of sine wave? Tell me, somebody. What's the form factor of sine wave? I think it's this. Everybody should remember this. If not, try to refer to copy and tell me it's okay. In this process, it's not only you're marking it, you're recollecting the concepts as well, right? So it's okay if you can refer the copy. Try to refer the copy. So it's 1.11 absolutely right. What about a sawtooth wave? For a sawtooth wave, what is the form factor? What's the form factor? That's a good response from everyone. Okay. For sawtooth. For sawtooth, it's no response. Nobody knows that. 1.15. For this also it is 1.15. For square wave, tell me what is the value. What's the value for square wave? See, these things, you should remember these things. You should remember these things. Okay. for square wave? Yes, absolutely right. It's 1 because these two are equal. So basically, this question and a previous question also pretty much similar. See, concepts, there won't be much beyond these concepts here. They'll tweak a bit. That's what I'm trying to say when I'm explaining these questions. Okay, in different exams, they may not exactly copy and paste the question, but they will tweak a bit. Concept remains the same. Underlying concept, you have to focus on that. Okay, so yeah, that's the answer. Square wave is the least among these. Okay, so that's it. So what's the difficulty this? What's the difficulty here? Anyways, moving on to the next. Go. I think this is also a question. So yeah, we'll have to take up that. Oh, for this also mixed answers, come on. How come for this people are opting different answers, huh? This is really crazy. Really crazy. Yeah. Not so impressive. I don't know, did you miss by chance or I still saw some option C's and option D, but mostly people have responded for this. That's a good sign. Okay. So yeah, admittance. See that these terms, admittance. What is admittance? It's Y. And impedance Z. What's the previous letter to Z? It is Y. Okay. So previous letter to Z is Y. This is impedance. This is admittance. Okay. What's the unit of impedance? It's ohm. What's the unit of admittance? It's mho. It's mho. Or what's the other unit? What's the other unit for admittance? Everybody. Everybody. And Z is equal to R plus JX. Be it L or C, that depends on plus or minus. Let's keep it like this. Okay. Yes, Siemens is other unit S. Now for Y, it is Z plus ZB. Or maybe plus or minus. That depends on whether it is inductive susceptance, B is susceptance, or inductive reactance, so susceptance, whatever, accordingly plus or minus will come. So X and B are reciprocal to each other. R and G are reciprocal to each other. Z and Y are reciprocal to each other. So admittance Y, impedance Z, L, susceptance B, reactance X. That's it. Okay. Siemens, mho, absolutely right. Okay. What's the unit for Z? Same, mho. Mho plus mho is equal to mho. Okay. That's pretty good. Next question on the screen now. I think we just saw that. You already answered for this. No, look at the question, Rakesh. Look at the question, what is asked. Province D is a little stylish. That's good. Blast. Nice, really nice. Because it's simple, so that's good. Good response. Okay. So, which of the following is the SI unit for SI unit is asking for. So Siemens, we've seen that we call it mho. That's what ohm inverse. You can call it as mho or ohm inverse. See, ohm, you write it reverse, it's mho. Okay. Ohm, you flip it, it's mho. Flip the symbol, writing also from the other side, you know that already. Reciprocal or ohm inverse, you can say, or Siemens. So accordingly, these answer. Okay. That's a good one. Let's go for the next. On the screen now. So we got 3 more questions. Okay, of course I got a lot more, but for this session, just 3 more. Okay, so then after we'll go for the next part of the circuits, which is actually AC circuits. Okay, these are the fundamental parts of AC circuits. Okay, in the next part, maybe in the next session, next lecture, we will talk about the circuits, AC circuits, power. That's going to be a little more interesting. Okay, because people normally do get confused between these, phasor diagrams, all this stuff. But once you attend our classes, obviously, that's pretty much easy for you. Good, good, good. That's a great response. In less time, you guys responded nicely. हर चीज को. Okay, time's up. If the impedance of an AC circuit is 10 at an angle 60 degrees, then the resistance in the circuit is, I don't know, I expected everyone to respond on this, including Raghu, Emmanuel. Emmanuel responded. Raghu also responded. Rakesh has responded. Good. What about Sanjeev? Yeah, Sanjeev also has responded. Sampath responded. Raju responded. Ritesh, yeah, you guys have responded. Others, no response. If the impedance Z is equal to this, 10 at an angle 60 degrees, then the resistance of the circuit, how to find out the resistance? It's easy one. R is equal to, see, this circuit impedance is this much, means power factor angle phi is also 60 degrees, right? So you know cos phi is equal to R by Z. Cos phi is equal to R by Z. Simply R is equal to Z. R is equal to Z cos phi. Z is given to you 10. Cos theta, which is 60 degrees. Okay, it's actually theta, but for this circuit, theta and phi are same. Okay, for this circuit. So cos 60 is, don't use calculator, come on. This is half. Cos 60 is half. So answer is A. Okay, everyone marked it right. Everyone. Okay, that's really good. Okay, next one. Don't use calculator. Already in the class, I've been saying this is a popular number. 4 and 3 are the popular numbers. They may give 4 plus 3j or 3 plus 4j. This combo is a popular number, I said in the class. Okay, so just by looking at this without touching calculator, you should be able to answer this as well. And we saw some responses. That's good. Really good. I think all the guys who have responded, they didn't use a calculator. Ramesh, good. Rakesh, Sampath, Sanjeev, where is your response? Yeah, your response is there. Ritesh, your response is first. Raghu, where is your response? Bang, time's up. All are correct responses. Very good, keep it up. So here, 4 plus 3j or 3 plus 4j is a popular combo. For this, z is equal to 5. Z is equal to 5. You don't have to say that. You don't have to calculate for that. Simply this. Okay, it's cost for power factor. Just as in the formula, R by Z, 4 by 5, which is 0.8. Okay, multiply both sides with 2, 8 and 10. 8 by 10 is 0.8 and it's plus j. So this is definitely lagging. Okay, so whenever you see this 4 plus j phi, directly you can keep 0.8 lagging. Okay, can you tell me what is the corresponding sine phi for this? I want everybody to respond. What is the corresponding sine phi for this? Yeah. What is the corresponding sine phi for this? Very good. Very good. You should remember this 0.6 for this combo. Okay, for the same, can you tell me what's the angle phi for this? What's the angle phi for the same? Cos phi is 0.8. What's the angle phi? Yeah, that sounds great. That sounds great. It's 36.86. Okay, 36.86. Nice, guys. Very good. Moving on to the next. Here you go for the next question. That's good. So the question, the definition itself is gave it in the question. Complete definition of RMS. When you're having an issue in understanding the RMS value, you can read this question. Definition will be recalled. Okay. Time's up. We got decent responses. Somebody is thinking it's C. Anyways, that's okay. Let's see what is right actually. See, guys, when you're practicing also, don't think that you are attempting to get some good marks. That's not the only objective. During your practice session also, your objective is to learn as well. Improve your learning when you're solving questions. Okay, not the marks. If it is right, okay, what's the analysis, how much time you're taking, how nicely you're approaching it, how your approach is. If it is wrong, in which part you went wrong, you have to analyze that. For any test, analysis is a key aspect. If no analysis, there is no use of attempting a test. Okay, for marks, to check the marks, exam is the one way to check the marks. Okay, so at the beginning you should not check your mark or performance or your rank. At the beginning you have to, when you're appearing the test, you have to focus on learning, improving your learning. Okay, anyways, moving on. The RMS value of an alternating current is given by a steady DC current which, when flowing through a given circuit for a given time, produces the same heat as produced by AC when flowing through the same circuit. The less heat produced by AC when flowing through the same circuit, more heat, what, 14.4. So basically, AC means the RMS value is defined. The definition of RMS value itself is in such a way, when you're allowing, because AC is continuously changing, what is the effective value I should take? I'll take a number, I'll call that number as an effective value, provided if that number, same value of DC current if I give, it should produce the same heat if I give for same time to the same circuit. Okay, that's a basic definition. That's a basic idea of the RMS value, and that effective value we'll call it as RMS value, which is A. RMS, how nicely it is given. The name is also such a nice way it is given, RMS. Okay, I think you know the beauty also behind the name. Okay, I think the last one, bang. That's a poor response for this. Okay, time's up. I don't know. How come you missed this one? This is one of the popular ones. If you mark this wrong, or if you're not knowing how to handle this, means it is pretty much clear that you're not aware of, you're not confident about the phasor diagrams. That should not be the case. If you're from electrical, definitely these phasor concepts, AC circuits is a key thing for any exam. You name an exam, this is important directly as well as indirectly. Okay, directly as well as indirectly. Your career is completely this phasor diagram concepts. Okay, so now whenever you see this, two waveforms are given, two sinusoids are given. This is also sinusoid, this is also sinusoid. Two sinusoids are given. It's asked the relation, the phase relation between them. Then immediately you have to recall this amazing diagram. Some people will start drawing from plus sign from here, or maybe plus sign from here. It's okay. Okay, anything is fine. So I'm just, for now, I'm marking this one as a plus sign. So this will be plus cos. Plus sign, plus cos. So if you keep here, you can rotate this entire diagram 90 degrees. Okay, in any direction it's okay, because we want a relative angle only. Okay, it doesn't matter where is position here, 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 because I want two angles. This is plus sign, so this will be minus sign. And this is plus cos, this will be minus cos. This structure you have to make first. Okay, this figure you have to make first. Once this is ready, now think about this. V1 is Vm sine. Now you write it omega t minus 30 degrees. Okay, so both are having same frequency. So now V1 is minus 30 degrees. Sine plus cos plus sine minus 90 degrees. Plus sign means this is plus sign. Minus 30 degrees means this side or this side, lagging, minus is behind. So this is V1. V1 is this. And this angle is 30 degrees. Minus is already included because that's why I'm drawing it this way. Lagging I'm drawing. Okay, this is V1. Now coming to V2. V2 is plus cos plus 10 degrees. This is plus cos. Minus is lagging, plus is this way. So this is V2, 10 degrees. Now the angle between these two is how much? 90 plus 10, 100 plus 30, 130 degrees. 130 degrees. And in the class, I think phasor diagram never be so easy without PiSquare. PiSquare, we done amazing animation on that. Even on YouTube also it's there. It's one of our popular videos also. PiSquare phasor diagram. Okay. So normally students do have a lot of complaints regarding this phasor diagram, but we made it so easy. Once you watch that, things will be amazing. You will be able to draw for anything. You'll be able to draw the phasor diagram. You'll be able to tell whether it is lagging or leading very easily. Okay, I think you got that as well. So V1 and V2 angle is 130 degrees. Now which one is leading? Respond. V2 is leading. V2 is leading. So 130 degrees, V2 leads, or V1 lags V2. That's fine. Both are equally valid. You can say V2 is leading or V1 is lagging V2. Both are same. We have to just, this is in the picture form. This picture is shown in the writing form here. So answer is B. And everybody marked it right. Okay, whoever is marked, but the markings are less. That's true. But yeah, what else can be done? So that's the end of this beautiful session. I think you must have learned some interesting points. Okay, and the objective of appearing MCQs. Okay, when you're looking at the questions, this is how we should go for it. That's the end of this lecture. See you in the next lecture. Now, if you have any further queries, Last line of the question. Last line of the question. What do you mean, Ritesh? So you can say V1 lags V2, or maybe V2 leads V1. V1 leads V2. This is not a proper way of saying, okay? V2 leads V1 by 130 degrees. So these two are our conventions. Either you can say this statement or maybe this statement. Both are valid statements. Okay. According to our terminology, we will say either of these. Okay. Now, anti-clockwise mention method. The anti-clockwise direction of rotation of the phasor may be taken as positive. No, that's there is nothing new in this. The anti-clockwise rotation of the phasors is a normal rotation. Phasors rotate in anti-clockwise only. Okay, so he explicitly mentioned that line. Okay, doesn't really, if it is not mentioned also, we'll take the same anti-clockwise rotation only. Okay, that's what I'm saying. You're not understanding this concept means phasor diagram, maybe you're not clear. I think just watch PiSquare video on YouTube itself. Free video is there. Phasor diagram concept, PiSquare Academy. Amazing, mind-blowing animation you'll get. And with that, I think you will be able to do any phasor diagram. Okay. Yeah. Now, any further queries? Or anything on what we discussed so far? If nothing, catch you in the next session then. How is the preparations going on? Is it going good? Bolo yaar. Tritish. V1 leads a V2. Ha. That also you can say. V1 V2 leads 230. Yeah, 230 degrees. You can say that. Nothing more? Okay then. Have a good time. Bye-bye.